Hello students, next topic is cells, EMF and internal resistance. For this I'll make a series of 3 lectures. First of all we'll only study about cell. Okay, cell you can say it is mother of any circuit. Without cell the circuit can't run. Okay, so what does it does? It maintains the potential difference which causes the current to flow. Suppose this is a cell. Okay, what does it do? This is the cell. It maintains the potential difference between these two parts so that the current can flow. If the potential difference between these two will become equal, then no electrons will flow, so the current will also stop. So what does it do? It maintains the potential difference between this. Suppose here it is 1, here you can say 0, here it is plus, here it can be minus, it can be anything, but it maintains the difference between this so that the current can flow through the circuit. Okay, second point, it gives electrical energy to all the circuit elements. Okay, you can have multiple circuit elements inside it. You can have a resistor, or you can say capacitor, or anything like this. What it does, unless and until you don't have cell, no current will flow and no energy will be given to it. Also the energy, by this you will study this in the later part of the lecture, that it gives an exothermic reaction which gives energy. Okay, we'll study it later on. Okay, now there are few points to be remembered. First thing, cells do not produce charge or electron. Suppose this is our cell. Okay, I'll put a small resistance over here. Okay, so whenever there is anything, whenever the electron flows from any substance, okay, there are no new electrons produced by this, but what it does, it just due to the potential difference, if this is positive and this is negative, electron will move in this direction. Okay, from here it will again start moving from over here. So what does it do? It does not produce any new electrons, but it only allows it to flow, which will be shown in the second point. Cell forces the already present free charges to flow. I will repeat, cell forces the already present free charges to flow, because here there is a potential difference. What it will do, this positive potential difference will try to attract the electrons. So what it will do, it will try to force the electrons to flow. Okay, and from here negative, it will again repel and try to move it in the circuit. So what it does, the cell, it keeps on flowing the electron. The electrons, free electrons that are already present in the system will keep on flowing due to this potential difference that is produced by the cell. Okay, next thing, electron flow from lower potential to higher potential. Okay, electron will flow from lower potential to higher potential. It can never flow from higher potential to lower. The opposite direction is not possible for electron. Okay, this is not possible. It can only go from higher to lower. Okay, it cannot go from lower to higher. Okay, and current is taken in the direction opposite to the electron flow. Okay, now suppose we have this simple circuit. Here it is positive, here it is negative. So electron flow will be from negative to positive. Okay, this is electron flow. Is it visible? Yeah, this is our electron flow from lower to high. Now the direction of current will be opposite, that will be taken in the direction opposite to the electron flow. Okay, so I will be in this direction. Here I can say it will be in this direction. Here it will be I. Okay, this is just a convention that current is taken from positive end to negative, from positive terminal to negative terminal. So it will be in the direction opposite to the flow of electron. Okay, now what will go? We'll move ahead. We'll study how the potential is done. Okay, it is just about the chemistry of cell. Okay, it is chemistry of the cell. Now what it does, it converts chemical energy to electrical energy. Which is used in the form of cells. Okay, simple example, you have studied in your chemistry, you will be or you might be studying galvanic cell. Okay, this you have I think already studied in your chemistry subject. Okay, so this is nothing but a type of chemistry. Okay, now we'll do it over here. We'll take a box. Okay, now we'll insert two plates inside it. Okay, we'll connect the circuit or a resistance. Okay, we'll fill this with electrolyte, that is conducting material, or which will allow the current to flow through them. Okay, we'll write electrolyte. Electrolyte is nothing but conducting solution. Conducting solution, or something which allows the current to pass through it. Okay, now what happens during this? A chemical reaction takes place, due to which a potential difference is generated. So what will happen? On one side it will start collecting the negative charges, and on the other side it will start collecting the positive charges. Suppose the negative charges are collected over here. So what happens in this? How this will be negatively charged? Because the electrons from this flow from here to here. Okay, so here it will be positively charged. Okay, so now what we'll do? Here there is excess of electrons. Excess of electrons will start moving in this direction from negative to positive. Will start moving from here. It will go over here. It will be attracted by the positive charges. Okay, inside the cell what happens? Inside the cell it moves from positive to negative. Okay, this is because of EMF that we'll be studying later on. In the next lecture we will know about it. Just now we'll just talk that electrons from here, it is moved to here, so this will accumulate negative charges, and from this again the charges flow towards the positive side as it is attracted by the positive side, and here it is repelled. Okay, now the direction of current will be opposite. Okay, now here we can take that potential difference of this plate will be negative. Okay, V negative we can say, of this will be positive, V plus we can say. Okay, what are this? These are electrodes. Okay, this and this also, right over here, electrode. Okay, now one will be cathode and one will be anode. We can say this is cathode, the positive one, and this will be our anode. Okay, this will be our anode electron. Okay, now what happens inside this? It will do exothermic redox reaction. Okay, this happens inside the circuit. What is exothermic? Which releases energy. Okay, which releases energy. And what is redox? It is reduction plus oxidation. Reduction plus oxidation reaction that will take place inside this system. Okay, so what happens? When is this released energy used, and what happens in reduction oxidation? Okay, so what happens over here? The electrons move inside this. It will be attracted by the positive, so it will directly flow from here to here. But now what happens? Now electron needs to move from here to here. So can it move? Can the electron be attracted towards the negative potential? No, it will always be repelled. So what you need to do? You need to give some energy to it so that it can move towards this point. So what is the energy? The energy that is released by this reaction. Okay, the reaction between this thing happens, okay, in the electrolyte. So due to the exothermic reaction, what happens? Energy is released, and that energy is utilized by this electron to move from positive terminal to negative terminal. So in short, we can say there is some extra additional energy that is other than the electrostatic energy, which will help the electron to move from here to here, that is from positive to negative terminal, which will conduct the flow of electrons, which will keep the electrons flowing through the circuit. Okay, I hope this much portion is very clear to you. So in next lecture we'll be talking about the EMF that is produced between the things. Okay, till then stay safe, have a nice day.